Today's lesson is on graphing parabolas. First, let's talk about some features of a parabola. A parabola is just something that's shaped like a curve. It is not a straight line. It only has one curve. The direction can either be up or down. I remember what this should look like by remembering that this is up like a cup or down like a frown. Which one is this? Is this up like a cup or down like a frown? This one is up like a cup. The x-intercepts come from where the parabola crosses the x-axis. It sort of helps anchor us to the graph. That's why it can also be called the roots. What are the x-intercepts in this case? You should have said that the x-intercepts are -1 and that x could be equal to 3. Sometimes we need additional points to help us flesh out what the curve looks like. One thing that might help us is by finding the y-intercept. We can always find the y-intercept by putting in 0 for x. In this case, our y-intercept is 0, -3, right here. Our line of symmetry helps us show where the parabola is cut into a mirror image, cut into half. It is always x equals something. In this case, it is x equals 1. The vertex is always either your maximum or your minimum point, your top point or your bottom point. It's where the curve sort of happens. The vertex comes from your line of symmetry. It is always going to be on that line of symmetry, so the vertex always has the line of symmetry as its x value. What is the y value that matches with this vertex in this case? You should have said -4. The vertex there is 1, -4. So the shape of a parabola is a curve. That direction can either be up like a cup or down like a frown. The x-intercepts are where your parabola crosses the x-axis. The y-intercept is where the parabola crosses the y-axis, and you can find that by substituting x for 0. The line of symmetry cuts your parabola in half. It's always an x value because it's always a vertical line. In this case, it's x equals 1. And your vertex always falls on your line of symmetry. It's either your maximum or your minimum point. In this case, it's your minimum point, and it's at the point 1, -4. Let's go through our steps to graph a parabola. You should have your notes out, and you should be ready to write each step as we go. Step 1 is to put that equation into standard form. This is nothing that's new to you. Standard form is y equals ax squared plus bx plus c. Y by itself equal to some number with an x squared plus some number with an x plus a constant. Sometimes we put 0 in for y. We do that when we need to find the zeros. We find the zeros by factoring or using the quadratic formula. Step 3a is to find that line of symmetry using this formula, x equals -b over 2a. Again, make sure you're writing this down as we go. This is the x value of the vertex. And step 3b is to substitute into the standard form equation to find the y value of the vertex. That vertex will always be x, y, some point. Remember, the x value comes from the line of symmetry. The y value comes from you substituting back into the standard form. And then step 4 is using substitution to calculate at least 2 other points on the parabola. You usually want a total of 5 points to be able to fully flesh out your parabola. Make sure you've written all of these steps down before we move forward to the next slide. So let's go through an example. Suppose we want to graph the equation y plus 3 equals -x squared plus 4x. We want to start by putting that equation in standard form. So far I have y plus 3 is equal to -x squared plus 4x. I need y to be alone if this is going to be in standard form, so I'm going to subtract 3 from each side. So y equals -x squared plus 4x minus 3. I do that so I can identify my a, b, and c for use in equations. A is -1, b is 4, and c is -3. So far I've just put my equation in standard form and identified my a, my b, and my c. None of this should be new information to you. Step 2 is to find those x-intercepts by substituting 0 for y. I'm solving using either the quadratic formula or factoring. Let's try factoring first. Remember, factoring doesn't always work. If it doesn't work, then we can use our quadratic formula. So let's check to see, can we find two numbers that multiply to be a times c, which is 3, and add to be 4? I can. Those numbers are 1 and 3, so I'm ready to factor. I'm just going to leave off the y while I factor because I'm finding this equal to 0, remember, because I'm finding the zeros. So negative x squared just comes down from my standard form. The 4x turns into 1x plus 3x, and I bring down the constant, which is negative 3, and that's all equal to 0. I'm now ready to factor by grouping. Remember, there's an invisible 1 in front of my x squared here. A common factor for negative 1 and 1 is negative 1. I'm going to bring down my x. Sorry, that's my dog sniffing that you hear. Negative 1x squared divided by 1x is x. 1x divided by negative 1x is negative 1. 3x and negative 3 have a common factor of 3. 3x divided by 3 is x. 3 divided by 3 is negative 1. So now this is factored. X minus 1 times negative 1x plus 3 is equal to 0. I'm now going to use my zero product property and set both of these equal to 0. I'm going to find x minus 1 equal to 0, add 1 to both sides, so x equals 1. And I'm going to find negative 1x plus 3 equal to 0, minus 3 from both sides. Negative 1x equals negative 3. Divide both sides by negative 1. And so, sorry, I've run out of room, x equals 3 here. So my x-intercepts are from my zeros, which are 1 and 3. So again, this is not something that's new to you. You should already know how to use factoring and the quadratic formula at this point. Here's my origin. I want to find the x-intercepts of 1 and 3 to be able to graph this. They go right there. There's 0, there's 1, and there's 3. I'm now starting to see my parabola take shape. To continue, I want to find my vertex and my line of symmetry. I'm going to use the equation negative b over 2a. Remember, I identified my a, my b, and my c already. Negative b over 2a becomes negative 4 over 2 times negative 1. That becomes negative 4 divided by negative 2, and that's positive 2. That's my line of symmetry. It is a vertical line through where x equals 2. So this line right here cuts my parabola in half. My vertex is going to fall somewhere on that line because the vertex is in the middle. I use that number to help me find my vertex. Remember, my vertex is going to be 2 comma something. To get the y value, I just substitute back into my standard form. It's negative 2 squared because it's negative x squared. There was a negative in front. X is 2, and then I'm subtracting 3. 2 squared is 4, with a negative on the front becomes negative 4. It is not negative 2 times negative 2 because this was a positive 2. There's a negative stuck on the front here. It's 2 times 2 with a negative on the front. Plus 8 minus 3. Negative 4 plus 8 is 4. 4 minus 3 is 1. So my vertex is 2 comma 1. It's right there. So this sort of looks like a V shape right now. In order to make this look more like a parabola, I need at least 5 points. I already have 3. Let's get 2 more. An easy way to find another point is to make y equal to 0, or excuse me, is to make x equal to 0 so that I can find the y-intercept, because that mostly just makes my x's disappear. 0 squared is just 0. Negative 0 is just 0. 4 times 0 is just 0. 0 minus 3 is negative 3. I have now created another point on the parabola, 0 comma negative 3. So this is 0, and I can go down 1, 2, 3. Now, I like to use that line of symmetry to help me find an additional point. Rather than try to calculate it by hand, I can use the fact that this is a mirror image. If there are 2 spaces between that point and the line of symmetry, that means on the other side there should be 2 spaces and another point. That is the point 1, 2, 3, 4, comma, negative 3. I now have my 5 points. Oops, sorry, that's not a very good curve. And so I can flush out my curve there. I always put arrows on the end to show that it keeps going on forever. Let's try another one. Let's take a look at our equation. Y equals negative x squared plus 2x plus 1. You decide, is this in standard form? Yes or no? Yes, you should have said this is in standard form. It's got the y first equal to some number with an x squared. There's an invisible 1 there, plus some number with an x, plus a constant. Now we're ready to find our x-intercepts. There are two ways that we can find our x-intercepts. The first way I'm going to try is factoring. I'm looking for two numbers that multiply to be a times c and add to be b. So I'm looking for two numbers that multiply to be -1, but add to be 2. Is this factorable? What do you think? You should have said no. There is no whole number or integer that multiplies to make -1 and adds to be 2, which means I need to use my quadratic formula. Quadratic formula is -b plus or minus the square root of b squared plus -4 times a times c all over 2 times a. I'm going to simplify what's inside the square root, so that's -2 plus or minus the square root of 4 plus 4 divided by -2. 4 plus 4 becomes 8, so that's -2 plus or minus the square root of 8, all divided by -2. I'm going to find the square root of 8 on my calculator. The square root of 8, if I round that off to the nearest tenth, becomes, hold on just one second, 2.8 if I round to the nearest tenth. So that's -2 plus or minus 2.8. Notice I take the square root off, divided by -2. Now we're ready to split this in two using the zero product property. I'm going to split this up into -2 plus 2.8 divided by -2 and -2 minus 2.8 divided by -2. -2 plus 2.8 is positive 0.8 divided by -2, which gives me -0.4. -2 minus 2.8 is -4.8 divided by -2, which gives me positive 2.4. Now, it's okay for these not to be whole numbers. It doesn't mean that you made a mistake. That often happens when we have to use our quadratic formula. In order to graph this, I'm going to estimate. 0.4 is like 40 cents. It's halfway in between 0 and 1, but in this case it has a negative, so it's about halfway in between 0 and -1. That's kind of small, but hopefully, hold on. That's kind of small. It's okay for these not to be whole numbers. What we have to do is just estimate where they will go. So 0.4 would be halfway in between 0 and 1, but there's a negative on it, so it's going to be halfway in between 0 and -1, right about there. So that's -0.4. Positive 2.4 is going to be halfway in between 2 and 3, so that's 1, 2, and halfway in between 2 and 3 is right there. Now I'm ready to find my vertex. I'm going to use -b over 2a. Go ahead and calculate the line of symmetry on your own right now. You should have substituted in b as -2 and a as -1, so that becomes -2 divided by -2, which is just positive 1. And remember, that's a vertical line that goes through 1. So we're going to put it right through here. It's always going to be a vertical line for these quadratic equations. To find the y value of that vertex, I substitute into the original equation. This equation tells me how x and y are related. X is now 1, so I can replace all the x's with 1. Remember, I'm not squaring a -1, I'm squaring 1. 1 times 1 is just 1. With a negative on the front, it's -1. Plus 2 plus 1. -1 plus 2 is 1, and 1 plus 1 is 2. My vertex comes from the line of symmetry and the y value where I substituted in. So that's 1, 2, and it falls right there on my line of symmetry, right in the middle. Remember, I need 2 more points to flesh out the parabola. I like to find the y-intercept by making x equal to 0, because this becomes -0 squared plus 2 times 0 plus 1. That's just 0. That's just 0. And 0 plus 1 is 1. So that's the point 0, 1, which is right about there. And remember, I'm going to use symmetry to help me. If that point is 1 space from the line of symmetry, then the other side has a point 1 space from the line of symmetry, and then I can just count over. That's the point 2, 1. And then I can just draw in my curve here, and that's my parabola. Remember, we can graph a parabola by finding the zeros, the vertex, and then a total of 5 points on the curve using symmetry. Thanks so much. Have a great day.